Okay, so now let's talk about NLP. NLP or natural language processing. So as the phrase itself says, natural language processing. So it has to do with anything where natural language is involved. And by natural language we mean typical languages, right? So part of NLP which deals with text is called text processing. But hey, you can actually do natural language processing also from images. So for example, if I go outside and take an image of all the shops, right? So there'll be a lot of text which is written on those boards, right? Those boards which talk about the name of the shop and so on. So I can do and there could be other images like business card scans, so or insurance form scans, and I can do a lot of natural language processing on those images as well. That said, natural language processing is also important to be done in the speech domain. So all of us basically use the speech to text natural language processor on our phones when we talk to our phones and we talk to these personal digital assistants like Siri, Cortana or Google Now. We are actually using this speech based natural language processing. So on this slide what I focus on is natural language processing from the text perspective. Okay. So the simplest application of NLP in text is spam detection. So given this piece of text, this email, can you automatically detect if this is a spam email or junk email, right? Now that doesn't just go to emails. The spam detection can also run over general documents. So general web documents, is it a spam web page or a good web page, right? There are other different aspects or tools inside NLP. For example, part of speech tagging, named entity recognition and so on, which we'll discuss in detail at some point. But these are all important, interesting tools which do things with the language in an automatic way. So remember in school we used to do this part of speech tagging. Given a sentence, the teacher would ask us, hey, tell me the part of speech of each of those individual words. Now we can do that automatically, especially for English. Of course, the entire natural language processing is language dependent. So a tool which works in English may not work well for other languages. And therefore, one has to keep in mind that if they are working with the non-English languages, maybe even other Indian languages, then one has to develop these tools sometimes, right? So that's that. Some of these natural language processing modules are very accurate, and that's what I've shown in green. So especially for English again, right? But while others have some accuracy, but it has like about 70–80% accuracy. And finally, there are a set of things which really work well, which really are in the research. So they don't really work well so far, but people have been trying smaller versions of these kinds of things. Okay. So for example, currently spam detection or part of speech tagging in sentences or figuring out named entities like person names or location names from sentences, all of this is doable. Okay. So also stemming, which is basically trying to figure out the root form of the word. So for example, affect, affection, affecting, affects, all of them have the same root form affect. Right. So and then tokenization, so where given a sentence you want to really figure out the words by themselves, these tasks really work reasonably well. Okay. Tokenization especially is a very important task when it comes to say Chinese or Japanese. It turns out Chinese and Japanese don't have any spaces. So unlike in English where space is a good delimiter to figure out words, in Chinese and Japanese there are no spaces at all. So how do you figure out where are the words? So but there are good modules which people have written so as to figure out what are the words, right? So tokenization is also a solved problem. Now there are certain other kinds of problems which are not very much solved, but there are softwares which do like 70–80% accurate softwares, right? So sentiment analysis is one such problem. So essentially, given two reviews, you want to figure out whether they are positive, negative, and so on, right? And sometimes you also want to automatically predict a rating for the review. So essentially, rather than just saying whether it's a positive review or negative review, you want to automatically say on a scale of 1 to 10, what do you think the user meant when they wrote the review? Okay. In general, most of these review websites also allow the user the flexibility to provide a rating, right? But there are use cases where there are no ratings at all. So for example, you want to do a research on your new toothpaste that you just launched. Let's say you launched a new toothpaste in the market, right? And you want to figure out what people are talking about it. Now, of course, you can also launch the toothpaste on Amazon, and on Amazon, people will write reviews for it, and they will also probably give you ratings. So essentially, scale of 1 to 5 or something of that sort, right? But a lot of people actually write about it on Twitter. And on Twitter, nobody gives a rating, they just write tweets, right? So one has to then do automated sentiment analysis and figure out how many people on Twitter have expressed happiness about your product, while how many others have basically said negative things, right? So that's that. Then there are other things like co-reference resolution, word sense disambiguation. We'll not go into details for now, but it turns out that many of these complex tasks are also, with certain accuracy, you can do these things, right? One of the most important ones of these is machine translation. Taking a sentence in Chinese and converting it into English automatically, right? Again, there are cases where machine translation fails miserably, but there are many other cases where it works reasonably well. Especially if you are a tourist, I think you can survive with the current machine learning platforms that are available. Okay. So, and then there are things which are like quite visionary, and it will be good to have very high quality ones, in generic form. But what we have now is some approximations of these things, and in specific particular domains. For example, for question answering, if you search on any search engine on Google right now, weather Hyderabad, it gives you a direct answer. It tells you it's 35 degrees, right? If you search for time Hyderabad, it gives you a very direct answer. It tells you that whatever is the time IST, right? It really figures out that, hey, you're talking about a particular time zone, and then gives you a very good answer. Okay. If you ask who is the current Prime Minister of India, well, it gives you a direct answer. All these factoid questions are nicely answered by search engines automatically. But there are questions of this form which are more of an opinionated questions or perspective questions. How effective is ibuprofen in reducing fever in patients with acute febrile illness? Google won't give you a direct answer for this. Okay? And that is why there exist such community question answering websites like Quora, Stack Exchange, where you go and put these questions where humans actually come and answer these. Right? The goal is, how many of such questions can you automatically answer? Okay? So if you can still automatically answer at least say even 5% of these questions, you reduce load on such systems significantly. Right? You reduce load on on real users who try to answer these questions. Question answering is not just for online community question answering websites, but also for call centers. A lot of people call Xbox customer care or any other product customer care, right? How can we deflect many of these questions and answer those questions automatically rather than real agents answering them and then charging per minute for whatever time they spend on the platform? Right? So that's that. Paraphrasing is yet another natural language processing module where you try to figure out that the two sentences XYZ acquired ABC yesterday or ABC has been taken over by XYZ are both similar sentences, right? Although they use very little number of common words, but they mean the same thing. Okay. How can you figure that out automatically? So if you can figure that out automatically, you can go one level up on this copyright infringement saga, right? So rather than saying that, hey, somebody is infringing my copyright by just looking at matching phrases, now you can actually try to figure out if a news story was really taken from other news story by just changing a few words here and there and making sure there are no repetitive phrases, but the meaning is exactly the same, right? So that's that. Then there is a use case on summarization, especially nobody wants to read like 50 news articles today. Nobody has time to do that, but it's very convenient to really read 50 different paragraphs which really very quickly help you browse through this news, right? Dialogue agents are becoming a hot trend these days. Everybody wants a chatbot for their domain. Okay? So essentially a chatbot like an Xbox chatbot which can really answer these queries automatically, right? Rather than somebody really talking to a real human agent to do the same. Now the difference between question answering and dialogue agents is that dialogue agents are much more powerful. These automated dialogue agents are supposed to respond to multi-turn question answering, so to say. So for example, the user comes and then asks, where is Citizen Kane playing in San Francisco today? Okay. The agent, of course, a question answering agent would just say Castro Theatre at 7:30, do you want a ticket? Okay. Now the question answering agent would forget the context, what the user said in the previous thing or the previous turn, right? but a dialogue agent would remember the context as well. Okay, so it will not. So the next time the user says yes, 2 tickets, the dialogue agent is not going to ask 2 tickets for what. It of course knows 2 tickets for what, and it's going to propagate that context until the entire conversation keeps going through. Okay, that's that. So and then of course the last one, which is a very important use case, is speech recognition. Speech recognition systems have improved over years significantly, and that is thanks to improvements in machine learning algorithms, deep learning algorithms, and so on. Right? So these are some of the modules which are studied as part of natural language processing. There are many more. Okay. Of course, we'll not go over all of them, but hey, all of these are very important modules which are very prominent under natural language processing. Right? One of them, is very interesting: automated essay scoring. So many of us have taken GRE test, right? So as part of these tests, students are supposed to write essays. Okay. Now, what is a good essay? So a good essay has a few things, right? One, it must follow the grammatical rules of English. It should not have any spelling mistakes. It should cover as many points on the topic as possible, as well as it should take up fresh points. Now, all of these 4 or 5 things a human grader can very easily grade by reading through the essay, but a human grader can't scale. So essentially, if you have 1 million people taking GRE every year, you will need to employ so many people so as to grade these. Scaling is one problem, being consistent is another. So you can of course employ like around 1,000 people to grade these million essays, but will all 1,000 follow the same grading scheme? That's questionable, right? So how about doing this in an automated way? Fortunately, thanks to NLP, there are automated ways of figuring out is there a spelling mistake, of figuring out is the grammar in the sentence correct, of figuring out are enough number of points on this topic covered. Given a model answer, it's sort of trivial or very easy to use NLP modules so as to figure out how many points from the model answer have been or a model essay have been covered in this essay, and so on. Okay, so that's about natural language processing.